Okay, everyone, can anyone please confirm the audio before we get started? Just we want to make sure that you guys can hear us and see us clearly. So please confirm in the chat. Thank you, guys. So welcome. Hello, everyone. Good morning, good evening, good afternoon. Good afternoon, good evening. Assalamu alaikum wa rahmatullah. It depends on from where you are joining the program. Welcome to Big Bang Data Science Solution NLP 10-week free program. We are now in week number 7. So in week number 1, we learned about the introduction to data science, data analytics. Then in week number 2, we learned about Jupyter Notebook and introduction to Python. Then in week number 3 and 4, we learned about the NLP processing part 1 and part 2. Then in week number 5, we learned about the feature extraction method. Then in week number 6, we learned about the text classifier. Then today we are going to learn about the collecting data or extracting data from web, from online. This is called web scraping and API. And Professor Ed Bourjak will be driving for today. So before I pass the floor now to him, so please make sure that you have access to the canvas. Now please have access to the canvas, so you can actually if you want to have access to the training materials. Yeah, sorry guys. So if you want to have access to training materials. Okay, let me show you, just take you, navigate you through the platform before I pass the floor to Ed Bourjak. So we are now in week number 7. Click on the training materials, and it's going to take you to a Dropbox where you are going to see all weeks. Now click on week number 7. You are going to see all the Jupyter notebooks that we are going to use for tonight. So that being said, and without wasting your time, I'm going to pass the floor to Ed Bourjak. Ed, please go ahead and share your screen. Ed, can you hear me? Please go ahead and share your screen. Okay, waiting for Ed to share his screen. Here we go.
Audio is on, sharing screens available. Can you confirm?
Yes, I can see you.
Great. Ready to start,
Yes.
folks?
Yes, go ahead.
Oh, I'm sorry. Yeah. So, folks, in Canvas, there will be the download link for these files, which you physically see here. Grab them, put them on your hard disk somewhere, and make sure you know where you put them. Typically, you'll download in a downloads directory, and this will be the structure on a hard disk. So the important things are these Jupyter Notebook files, the ones that end in IPYNB. We'll look at every one, but maybe PyBytes, no. So this topic is about getting data from websites. So I'm going to talk for about 2 minutes. So while you're downloading this stuff and putting it on your hard disk and making it reachable by your Jupyter Notebook, see that has the same structure as the physical files on my hard disk. So in real life, you know, there's different forms of formats, I guess, or structures of data. A CSV is a very popular one because it's rows and columns, and it's very structured. Some cells might be empty or null or outliers, but that's something to deal with. We're here today to deal with getting data and also to process it a little bit with regular expressions. So this is a gentle introduction to getting data from websites. Now, why would you want to do that? Well, what if your data is very timely? You did some marketing stuff. You did a base study of the sentiment of your customers, and you 2 weeks ago, and you did it now. Then you put out a marketing campaign targeting maybe certain people or maybe everyone or all your customers. And then you want to feel, or maybe you just release a new product, and you give it some time to settle out and see what people are saying. And then you run the same program again, and you see if your customers or clients' sentiment is changing about your company, your product, your marketing campaign. And how do you do that? Well, that's done on a website. So the data is not logged or processed, especially not in any structure. So there's different kind of structure of data. So and these are just my notes. I'll make them available to you. Structure is data. The data is structured. Now, structured is now. If anybody has an idea, they can chime in anytime they want. Structured, it could be CSV, comma, separated values. So that's typically what you'll deal with when you first start learning machine learning and data science. Also, tab separated values, fixed field. It'll say column 7 begins at position 53 and goes to position 60. The next one starts at 61 and goes. So that's one you don't see much anymore, but I've had to deal with it. Or also SQL. You don't have access to the structure directly, but you use SQL to get to the data. Okay, and typically it comes back with tables. So then there's unstructured, which is the ultimate opposite end of the spectrum. And then there's semi-structured or half-structured or whatever you want to call it. And this is just a big breakdown, so it's not super formal. Although structured versus unstructured is big. And in between, how many categories you have depends on who you talk to. So semi-structured is some websites. Oh, when we say website, I guess sometime I'm going to slip today. When you get data from a website, that's a little bit weird. You really get you really scrape data or harvest data. In your computer guide, it's called scraping. You point to a web page. So you scrape one page at a time. And then you move to the next page and scrape the next page. So a real quick example is if you go to like a shopping catalog thing and you go shopping for hammers and there's 87 hammers. Well, it'll only show you the first 20. Then you hit the next button and it'll show you the next 20. You hit the next button. So it will be a sequence of web pages. We're not going to talk about that one today because you want to scrape all, whatever I said, 85 hammers until you get 20, 20, 20, 20, and then 5 more left over. So you want to gather up all the data about hammers. In other words, you want to scrape the data so you can look at it and do some data science, machine learning on it. So we'll make sure you remember you scrape one web page at a time. Okay. Unstructured, some web pages. And that's like really bad because you're searching for a lot of stuff. If anybody thinks of any unstructured data, natural language. Remember, when you say natural language, that's kind of why we're here. That's natural is what humans do. So that's reading, writing, audio, anything that's human related. And it's not there's structure to it, but ultimately it's tough. You've heard of it. parts of speech like noun, adjective, participle. That's important. And context is very important, but we're not going to deal with that today. So we're going to deal with this part right here. So we're going to deal with the semi-structured. So that's where we're at. Now, what do you deal with it when you get semi-structured? Well, you basically provide the URL to your code, and it doesn't render the HTML, CSS, or whatever, JSON or whatever. We'll talk about those. It doesn't render that text inside a browser tab. Instead, it gives you the raw text. Then it's your job to throw something at it to analyze the structure. Okay? So today, we're going to deal with beautiful soup. So remember, this is what we're going to talk about specifically today, beautiful soup and regular expressions. Beautiful soup job is to come in and you throw beautiful soup at the text of the web page. Now, if you were presented a bunch of text or a bunch of, you as a human, or even when you listen, you parse. You pull apart, let's go with text. You pull apart the text into sentences. If you're big, more so, more granular words, and if you're really crazy, characters. So you're parsing mentally all the time, listening to people saying, does that make sense? That kind of thing. Is the order right? That is what they said complete? All that stuff. So that's generally called parsing. And Beautiful Soup has an HTML parser and others. So your first big question is, once you get the text from the web, with the web server that normally presents the text to your browser, and your browser puts it or renders it in a browser tab, you're going to get the text. And it's your job, to do something with that text. You want to basically not write the code. You want to use a parser. Now, the question is, which parser do you use? Well, it depends what type of text they give you. So if it's HTML, Beautiful Soup is the go-to library in Python for HTML. If you have JSON format, it's very hierarchical. So that's so here's the formats: HTML, the semi-structured ones, I guess. The question is, are they structured or not? I don't know. JSON has, it's hierarchical. HTML, it's tagged. So it's not the ultimate unstructured. It's sort of semi, according to me. And here's others. XML. These are popular. These are not popular. These are the classics, okay? And we'll add things as we see. So we're going to look at a website that when you went to the website, it gave you HTML back. Well, it gave your browser HTML back. So you're going to look at it and parse it. And what that means is you're going to be listening for things you want to look for. So if you're at a shopping website for hammers, you might not care about the images of the hammers. You only care about the length, the weight, the manufacturer, the price, and that whole stuff. And you'll put those things into a table. And then you'll pass it off to the data science / machine learning folks, more of the machine learning, because not necessarily all the data is good. So here we go. So by the way, CSS is cascaded style sheets. Okay. So this is like the layout, and this is the content. So if you're not an HTML guy, person. You have to learn it a little bit. Same thing with JSON and XML. You don't have to be an HTML guru to parse HTML, because the beautiful soup HTML parser will do it for you. You just tell it what to look for. And that takes a little bit of investigation. You look at your data, you say, what's important here? What are some things that I could search for to get me to here, or to get me all the prices on the current page? You can say, find all the prices. And if it's the hammer 20 hammers per page, web page, it will give you 20 prices. And by the way, folks, I hope if you have a question, I'm not looking at chat. I'll be listening. So if you want to chime in, go for it. You should, in the background, be downloading the files. Okay. Beautiful Soup is a parser. So you tell it, find me the HTML tag, and there's tons of them. Find me the href tag. That means hypertext reference. That means give me the URL. So you want to find the next URL, or you want to find all the URLs? I'm sorry, all the hrefs. So you can do one or the other. And then you have to do things with it. You know, it gives you something or nothing, and then you work with that. Now, the classic is, in a perfect world, your data is perfect. You know, the website is perfect, and it never changes, or it rarely changes. A big problem with web pages, or getting data from web pages of any kind, doesn't have to be Facebook or anything. They change the naming, they change the format, they change the layout. So what worked today, no guarantee it'll work tomorrow, especially if they change the layout or, you know, the naming. Okay, so that's one bad. Web page or web scraping as a whole, especially if it's HTML, will break. So don't think you're going to write code and never have to look at it again if you write a parser. Okay, if you say, here's a web page, can you get the data from that web page that we care about, so that we can do some data science, machine learning on it? Okay, it will change. So if it breaks, your code didn't degrade, it's the site changed, and it changed. Okay, there's also simple, and we'll look at a few things you can do with the text that you get from a web page. The question is, it's a lot of searching, and also like changing or translating. So one is when you search, how to search. Now, the most simplest search is, you know exactly what it is that you're searching for. And you just type in exactly. Now, it's not Google search, okay? You're searching for price, P-R-I-C-E, and then they decided to change it to PR. Your code won't find it. So that's a very literal find. So the question is, can you support wildcards? Can you support weird formats? I want to search for phone numbers. Well, what kind of format is a phone number? Well, there's a few classic ones, and that's what you look for. Or I want to look for a web, a subnet mask on a URL. How do I find it? And that's, you can't search for anything. You got to say, I'm willing to take 3 digits, only digits, followed by 1 dot. No, it has to be 1 dot, followed by 3 digits, followed by another dot, followed by 3 digits, followed by another dot. And you'll say, well, I'm willing to, I said 3 digits. Well, what if it's only 23? Well, wait, you said you wanted to find 3 numbers or 3 digits. It won't work. So you want to get a more advanced search, and that's regular expressions. Okay, and most people, Oh, by the way, it's you'll sometimes, AKA, also known as, some people call it regex. No one pronounces this. No one goes around saying re. So they say regex even if they write it re. And if you feel like saying regular expressions, go for it. So if you ever see these regex things, and you will, for today, we will import re. It is a package inside. Available to Python people. So that's our code for now. Our general idea. Any questions about where we're going to go with this? Okay, so let's look at the code. You should have these files downloaded. I'm going to start with web scraping. And we're going to scrape a website. And this is a very simple one. So it's nice to start with a simple one. It's somewhat structured, really almost structured well. Whereas if you look at this PyByte thing, we're not probably going to hit that today. I scraped the PyByte's website. It's a place that stores Python code snippets. It's pretty crazy down here. So I'm not going to look at this. For advanced folks, you can look at that. I scraped the PyByte's website. So it's Python code snippets. PyBytes is a great place to be, but I decided to throw web scraping at it, other than looking at it in a browser tab. So folks, we're going to look at web scraping. Some people call it scrapping, but it's really SCRAPE ING, so not without the E. So I'm going to look at web scraping, and we're going to scrape a website. Okay, and we'll look at these other things as needed. Okay, ultimate is to start with web scraping and finish with RE regular expressions. So hopefully you got this in available to your Jupyter notebook. So we're looking at web_scraping.ipynb. And I strongly invite you to keep this sort of, wherever these files are, keep this available, because this web scraping will create a file. The ultimate goal is you're the web scraping guru, and they say, I want you to scrape this website. Here it is. Here's the URL. I want you to get this, and this. Okay, you say, okay, what do you want me to do? Well, ultimately is you produce a clean file of it web scraped. So we're going to look at a website, and we're going to come out with 4 or 5 columns, whatever. And the easiest thing to do is to use something that's available to Python that everyone uses. And if you're talking about a table, it's definitely Pandas with a data frame, rows and columns. So we'll create a Pandas data frame. As we get the data, as we scrape the data, we will look at it and be happy with it and say, okay, great. How do we make it persistent? Well, you want to write it to a file. So you can do all that writing to a file yourself. Please don't. Use something else. Pandas is the go-to library or package actually, to read and write files of any format that you could possibly think of. Okay? So you're a data science machine learning, you're scraping a web page. Hey, I'm going to produce a CSV so that you can throw it down the aisle to the data science machine learning people. Say, I got it. Here it is. Here is, I web scrape the page. Here's the data. Do your stuff on it, like natural language processing if you want. And I always pick sentiment analysis, because you'll see we'll be scraping quotes. But you can also do things like, hey, I got the quote. Not authenticate it, but do some fact checking on, is this a fact? Is this real? And you can add another column that says, the percentage of truthness is 0 to 1, and if it's 95% true, then yeah. And truthness is another discussion. We're not going to talk about it now. What people say is true on the web may not be true. So be careful. A lot of it has personal feelings. So take that into account. So here we go. Web scraping. I'm going to make it. I'm going to make it I'm gonna keep this. Like I said, I want you to keep this open because we're gonna create. This program will create a file that will save it as a CSV. If you see there's no CSVs here, it's going to create it. Now, Mo did allude that most people web scraping is an API. Definition of API, if you're an engineer, is you're making direct calls to the server. So this is not that per se. If you just call some functions or methods, some people call that an API. It's a stickler. Don't worry about it. Okay, but it's a way to get to data. Oh, web scraping in a general way is a way to get to the data on the web page. And I don't mean data meaning numbers. It could be anything. And I have an example. Way at the bottom, it scrapes images. I look for Baby Yoda images because I had nothing better to do. Anyway, here we go. Web scraping. Right. So it's specific. Remember, keep saying it's a web page. Okay. So the question is, is the web page structured or not? If it's not structured, you got a lot of work. But if it's structured, you got to say, well, what kind of structure do you have? Is it HTML, whatever? Is it XML? Then you throw the appropriate parser at it. Today we're only doing Beautiful Soup, so it's HTML. Okay, and it's a good thing to start with because it's not bad. How do you read the web page? So you got to get the text of the web page. These are at least three. I'm sure there's more. We're going to use requests, okay, today, and it's going to be quite really simple. So you're going to use requests, and you say read this URL, and you're going to get some stuff, and then that's the end of it. So you're not doing anything elaborate today with requests or any of these other libraries, or to read those, to go to a URL and get the text of the web page. Okay, so there's parsers, which are really, 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 really simplistic. Most people don't deal with that low-level stuff. They use a framework, and here's three. Oh, I'm sorry. There's plenty more. Here's Beautiful Soup. Here's Selenium, and here's actually people say Scrappy, or Scrapey, but it's scraping. They have it. They all have their pluses and minuses, and these are only a little bit of it. This is the gentle introduction to getting data from a web page. So you want to go easy. So here's the user-friendly one. Beautiful Soup is user-friendly, very simple to use. Okay, but it doesn't work on everything. Oh, by the way, Beautiful Soup has other parsers. Okay, it can look at XML. So it's real simple. Okay. Selenium is a whole suite or framework, and it came from automated testing. So if you're a DevOps kind of person or an ML ops person, you will be a Selenium kind of person. So it's great for that. But as they developed, they did realize it was good for other things, like parsing web pages. Okay. Leave it alone. We're not doing Selenium today, but if you hear about it, it's the same as Beautiful Soup, just different. And it's definitely more advanced too. Okay. Scrapey or Scrappy, extremely efficient. So when you do a search in Google, it's not doing a search. It's checking its index of stuff that it spidered. So spider crawls, so it's a web crawler. And maybe Google web crawls every 10 minutes. So you're only getting the last, just go with the flow, it is 10 minutes. You're only getting the access to the index that Google did in the last 10 minutes. So it gathered information about the web in the last 10 minutes. So you're not doing a, quote, live search. Okay? So how's it doing it? Many ways, it's not doing it with these simple tools, Beautiful Soup or Selenium. It's doing with something more advanced, something along the line of Scrapey or Scrappy. It's elaborate. So you don't go here unless you, if you know object-oriented programming, this is it. You provided objects and classes and methods, and it uses those names to scrape websites, meaning a bunch of web pages, ridiculously well and fast. But you have to be really, you have to know a little bit about Python, okay, to go there. Okay, here we go. Finally, let's do some things here. These are just two cells I like to run. This one says when Jupyter Notebook puts out an output, say it's 20 lines. If it goes more than 20 lines, it starts putting it in a scrolling window. I don't like that. And you could also say, I want to scroll only, after 40 lines. Well, I want infinite. I don't want any scrolling output cells. I'm going to run this one. So this is cell 1 that ran inside this Jupyter Notebook. And this thing, what if I say A return B return C? In most environments, it only tells you the value of the last thing. In this case, you have a new line B, a new line C. It would only tell you the value of C. So what this says is, I want you to tell me everything all the time. So if I said A, B, C, 3 lines, it will tell me the value of A, value B, value 3. That cell will have 3 output cells. So it makes life easy. I don't have to say print A, print B, print C. So these are just neat things to know. There's a bunch of these things. These are 2 popular ones I use. Finally, we get to, we're not in Beautiful Soup yet. We got to get the text of the web page. So I'm only doing requests. Oh, I'm sorry. The request pack. I'm using the requests package to get the text of the web page. So here we go. You got to import it. Now, real quick, I want to find out a lot of information about requests. So inside NUtils, you have that file. When you import files in Python, they have to be source code. They have to be .py files, or they have to be a bunch of .py files. Okay, NUtils is a simple one. It's just one .py file. There's a bunch of stuff in there. There's also an inspector function. So I'm going to throw inspector function at that request library, and it's going to tell me a lot of things about the request library. So NUtils is something we did in the Python course. So here we go. And it's just going to tell you a lot of stuff. Try not to read all this stuff. I mean, it's important if you're like an intermediate to advanced Python thing. But the important part are these things. There's 40 attributes, or properties, if you like the word properties. There's 11 methods of requests, and it's 16 classes. And it's a package. Lovely. Great. Okay? Lovely. It's nice to sometimes know about what you're looking at. So throw inspector at whatever you're looking at. You could throw inspector at the number 5, or inspector at the number at a list of Python lists. It'll tell you a lot of neat things about it. Let's talk about Beautiful Soup. Beautiful Soup's a package. I'm sorry, real quick. This is exactly correct. So be careful, because Python people are very loose with their terms. They say one thing and everyone just glances around and they say, okay, yeah, I know what you mean. So being super accurate is not necessarily a forte in Python world. When they say Beautiful Soup, there's actually 2 components. There's BS4, and that's a package. It's a collection of .py files. Some people might call that a library. Call it a package, okay? Beautiful Soup. Oh, I'm sorry. BS4. This is the exact. And these 2 bolts are exact. BS4 is a package. So you import BS4. Okay, sounds good. Well, lovely. We have a package. We have a bunch of stuff. Okay. Well, you want to start using it. So the way this is spelled, it's camel case, Beautiful Soup, 1 word, no underscores. It's camel case. That's usually the convention in the object-oriented world for classes. So if I wanted one of these things, I would say, something equal this spelling. So it's going to create me this object. Great, lovely, this theory. So here we go. Import BS4. Yeah, that's the package. That is, quote, the library. Tell me something about BS4. Okay. Oh, yeah. So here are the attributes, properties. Here's the methods. Oh, there's methods, and there's the classes. Leave it alone. It's a package. Well, most people don't do that. What they typically do, this is the canonical form. Canonical is sort of like the default thing, or the canon. So when people say the canon of the text, it's like what the canon of Harry Potter books. You know, it doesn't follow the canon of the Harry Potter books. That means they did something weird here. But canonical is the normal way people do things. So if you're talking about beautiful soup, generic beautiful soup, this is what people will do. From BS4, import beautiful soup. So what are you getting? You're only getting this piece. You're only getting that class. What about all the other ones? No, you can't do C data. You can't do builder registry. No, you don't get all that. You only want this class. Okay? Right there. So you're saying BS4 has a lot of stuff up there. I only want this one piece. Got it. And we're going to throw the inspector at it again. There's a few functions in edutils. Inspectors, the one that's heavily used. But it's nice because you don't have to do a lot of stuff. It tells you a lot of stuff in English. So it's kind of cool. And wait, here's where the action is. When you do beautiful soup, you get 28 attributes, 92 methods, 33 classes. Don't worry about it. We'll talk about it. Real quick, I did mention find. So there's a lot of find. There's a lot of finds. See, there's tons of them. I kept going back and back and back. All of those finds. So there is a find that says, hey, parser, find me the next thing that looks like an href. So it finds the next one. Well, what if you say, I'm tired of this, I don't feel like writing a loop. Can you just find all of them? Yeah, find and find all are heavily used. Okay? We'll get there. Let's do a simple example. And if you're an HTML person, I'm sorry, if you're a web kind of guy, girl, person, yeah, that looks like HTML. This part right here. The triple quotes or multi-line comment in Python. So, hey, I have a variable. It's just called HTML because name your variables appropriately. And here's the HTML text. What are the HTML tags? Well, some HTML tags have a beginning tag and the equivalent end tag. And they are the same, just that the terminating tag has a forward slash in front of it. So it's HTML and /HTML. Well, there's also the div tag, which is very popular for us. We're going to be going after them a lot, or other tags that sound like that. So this says here's just a division or a divider. And there's a bunch of divs. You can say div class equals blah, div class equals blah 2, div class equals happy Halloween. You know, and you're looking for that. You're saying, I want to look at the div, but I want the class that looks like happy Halloween. I don't care about all the other ones. Oh, there's 2 of them. Oh, now I got to go think about that. So these are the kind of the thinking that goes on. So there is in this text string, there is an HTML tag. And if we say, leave it alone, and there is a div tag. And when you say, give me the div, you get all of that blue stuff, the highlighted stuff. You get beginning to end. Now, if you only care about this part, we'll figure out how to do that real easy. Real easy. So here we go. Here's text string. You print it out. Lovely. And then what you say is, here's the text. I'm sorry. It's a beautiful soup object. Okay. It's coming out of this beautiful soup initializer. It's roughly a constructor, but it's an initializer. So if you're into object-oriented and it's a constructor, you can say it. It's okay, but it's really an initializer. So you say, create me one of these beautiful soup things, objects, and initialize it based on this text string. Oh, wait, that text string. So you're feeding it this text string. And you're also saying, I want you to use this parser. So if you throw the wrong parser at it, it's kind of like, you're speaking English and I'm parsing in German. Nothing will make sense. So throw the right parser at it. If it looks like HTML, figure out how to say HTML parser in whatever parser you're using. In Beautiful Soup, it's HTML.parser. So if you're using Selenium, dig it up. It's probably not HTML.parser. It's something else. So understand concepts today. You're throwing a parser at text. Okay? Here's the text you got from somehow, from the web, of the web page. Then you say, I got to fire up a parser. It's good to look at this really quick whenever you get and say, oh, that's JSON. Okay, you want to dig up a JSON parser. Okay? Beautiful Soup does JSON also. So we're doing HTML today. So you're saying, hey, Beautiful Soup, create one of yourself based on this text and throw this parser at it. Throw your name of a parser. So here we go. So this is parsed HTML. So name things appropriately. Great. Sounds great. We'll print some stuff out after this. So what comes out of this? It's a Beautiful Soup object. Now, when you deal with objects, it's like, it's not just simple text. It's not just an integer. It has a structure. So you got to talk to that object. So what object? Well, in this case, this is a Beautiful Soup object called this, called parse_HTML. Now, if you're reading some Beautiful Soup object, some text documentation, most people will call it soup. They'll just say soup equals. So, it has nothing to do with soup. It's the Beautiful Soup object, and it doesn't have to call it something, so they'll just call it soup. And then you start talking to soup. You say soup.this, soup.that. So I called it, just because it's the intro, parse HTML. Hey, parse HTML, do something. What do you mean do something? Do one of these. Well, one of them. And yeah, do at least one of them, maybe more. Okay? So we're going to say, find me. Oh, by the way, find depends on what parser it is. Okay? So find is this HTML. So this better be HTML type looking stuff. Okay? So it's not like a search thing. When you do a find, it's looking for, in this case, since it's an HTML parser, it's looking for HTML tags. Okay? So if you said find div, it's going to look through from the beginning. Now, see a div, it's going to keep going to the end. Find me a div. Oh, and it said, and what if there's no divs? It will come back with an error. Okay, so you can keep finding until you can't find anymore. And it says, okay, I'm done. I can't find anymore. But we're not trying to blow it up yet. So there is a div right there. Okay. Now there's many divs. You can say div class equals, class name, div class equals address, div class equals zip code, div ID equal. So I'm looking for a div tag, but not every div tag. It has to be very special. I'm looking for the ones, oh, by the way, in HTML talk, this is a tag. This is an attribute. Nothing to do with Python's attributes, okay? So, like I said, you can have a div attribute that's a class. You can also have a div attribute that's an ID. There are two big ones you'll see. I'm not to teach HTML here, but here we go. So I'm going to find a div tag. I don't just want to find all the div tags or the general div tag. I want the one that is the HTML attributes that is a class. And specifically, I'm looking for the one that says class name, not the div class equals address. No, I don't want you to find that one. I want you to find the div class attribute. I know it, you had too many classes. With the class name this. Okay? And when you do that, you'll get this whole thing. the highlighted blue stuff. And that's like, that's a little too much. I don't care about the HTML stuff. I'm looking for content. I'm looking for the data. So you say dot. So you want the text piece of this, and you'll get this. Okay. So dot text is a big one. And dot text is an attribute you can scroll up. I'm not going to try to scroll up and down too much. So dot text is going to get it says I found a div class with the attributes. I'm sorry, I found a div with the attributes class name. Great, here it is. It's the highlight part. You say, you know what? I only want the text part, so it'll pull this part out. Stop writing code for that. So text found will be what a wonderful day. Period. Okay. I guess I ran this, so I'm going to run it again. So there it is. Now, just for fun, if you want to find out parsed HTML, parsed HTML. Yeah, there it is. That is beautiful soup object. So if you, and you can do this too, and we'll move on. So the classic thing in HTML, I'm sorry, Python is what is it and what's its data type? Yes. So you say, looks like text. No, it's an object. It's a beautiful soup object specifically. So you can't just start parsing this out like a string, and you don't want to do it anyway. Okay, you want to tell parse HTML dot find parse HTML dot find all, that kind of stuff. So let's go with it. Yep, there's the URL we're going to go to. So it's always nice at first to look at this because you're coming in cold. You may not have seen this before, and it's old. It's a few years old. So I copied this, and I'm going to open up a browser tab and just look at it like as what my browser would render it as, that URL. And there it is, from New York Times. Okay, some text, some bold stuff. Oh, there's some red stuff. Oh, the red stuff looks like dates. Oh, come on. Come on, please. Can I escape? Oh, please. Log in. Okay, well, oh, come on. I hope it works. Oh, I didn't mean that. So there it is. Hope they're not blocking anymore. But you see some structure here. We're going after these quotes. But it's not just a quote. Uh-oh. I hope I can get to it. Anyway, so okay, one more refresh. See if we can get it. So there's a date, there's a quote, and there's some kind of like a reference to it. Like, where is this quote? Sort of like an attribution. So you got a date. One more time. A date. Real quick. Blink. A date. The actual quote and some reference about where it was found or mentioned. It's kind of like the source of the quote. It's nice to have a quote, but it's like, is this real? Can I click on something and read about where that's found or where that quote was said and that kind of stuff? So we're going to get the text of that web page. So you talk to the request package and you say get. So that's the only method we're going to use from requests, and we're going to get the data. Oh, get the text. It's text. It's just a monster text string, okay? And we're going to just show it to us. And it's not just the text. There's going to be a few things. So it's going to be like a request object of some kind. Oh, well, remember this object. So you got to say dot something. So most people call it a response or result. Great. It's text. It's this stuff that came back from the web server, including the text of the web page. Status code is important. So if you ask for a web page that doesn't exist, the status code will be a 404 or other things. If you ask for the access to a web page and if I got other error messages, like for example, oh, this, I forget what error it is, but yeah, this web page exists, but you don't have the access privileges to it. You didn't give me the correct codes. So it won't be a 404. 404 says something is, you're asking for something that doesn't exist. Whereas another one will be, it exists, you don't have permissions. So if you ever saw that page, there's a status code, and that 404 is the status code. Well, the big one is, what's a good one? Well, there's only one good code, and there's a lot of bad codes. 404 is the one everyone knows. So let's just run this cell. So it's going to tell us the response. It's going to say, yeah, you got a response object. Good. Well, okay, next thing you say, you know what? What if, response. Tell me the code. If it's 200, you're good. Everything worked. And then you're going to say, show me the text. Show me the content. Yes, it worked. So here we go. It's not a Python course today, but when you talk to an object and you say, tell me about yourself, if it doesn't provide a mechanism, it will inherit everything from the base object, which would be something like response object at 0xFD78942. That's a default thing. It's like, that is the worst English message I've ever seen. And that's the one if they don't provide it. The response people were, the people who wrote requests, were nice. They said, if someone just talks to me and says, like, print yourself, I'm going to print this. I'm gonna sort of indicate that this is something to do with response, that one. And I'm going to give the status code in square brackets just because they felt like it. And then end of story. So when default one is really bad. It'll say request object at some hex address. Well, it's hex ID. It's not an address. So I asked for the status code only. Sorry about that. So it will be 200. Real quick. And the third one is the content, which I'll hold in a minute. But wait, this is 3 output cells. Yes. So it's kind of neat. I don't have to say print response, print this, print this. I could just say, show me all of them. And that came from here. That's the last time I'll talk about that. Right here. Yeah, the one that says, this one, the one that says all. Yeah. Now you can also say things like, show me the last thing, show me none of them. For some reason, you want people to have to say print. I would say none. There's about 5 different names you could say. All says show me everything. Not the default is the last one. So here we go. I'm sorry, back here. And the third thing we asked for was show me the content. And there it is. Okay, that's now you would say that's not structured. I don't know. It's one big monster string. Now you can argue, does a string have structure? It's one big string. Inside there is structure. You just got to go looking for it, and that's the job of the parser. So all we got is the text of the web page that is here. That thing. And we said, just show me the content. So we're going to be looking at content. Oh, and you should write your code properly. Like, don't continue your code. Only continue processing if you get a 200. You should write code like that. Meaning, if I typed it wrong, like here, I'll put an 888 there. See, it's a 404. Error doesn't. And if you look here, this is different. And you say, oh, no, look really close. This has nothing to do with Trump quotes. This is the web page that they would show if you displayed this. If you rendered this in the web browser tab. Oh, no, wrong. I'm sorry. There, better, I think. No. Okay, I'll just throw another number here. 888 or whatever I put in. Yeah, that thing right there is this text here. Okay, so don't worry about it. I am not looking at this text unless it's a 200, meaning it worked completely. everything. I went to the server exists, this and that, everything worked. So I'll run this again so we get the real thing. And there it is. Lovely. And by the way, folks, there are, if you're a Python person, you should start thinking about this. There's a few different kind of strings. This is a byte string. That's it's preceded by a lowercase b, or actually, it doesn't have to be a b. Then you may have heard of thing called f strings. It could be capital F. So it's little f. Everyone just uses little f, but it could be a capital F. And there's a thing called R, meaning raw. So just be aware that they are types of strings. And okay, so there it is. Right, there's the byte code. I'm sorry, it's a string. It's of bytes. Okay, leave it alone. So there it is. What do we got to do with this? We got to throw a parser at it, meaning beautiful soup. Oh, by the way, you see how long this text is? I don't have. It's not. It didn't open it in like a little scrolling window. It's showing me all of it. Now, be careful about this, because if your web page is like, this is a small one. Okay, visually it looks like visually, if you like printed it, it'd be about a page and a half. And there, but behind the scenes, it's very, very lengthy. But this is not as bad as, other web pages. So be careful about using that, infinitely long output cell command at the top to tell you put a notebook to not scroll, don't scroll, that kind of stuff. So let's just look at this really, really, really quick. Now, when you start parsing, think of yourself as an infant. You didn't, like right now, you're ridiculously good at parsing. People list, text that you're reading or audio, that kind of stuff. But you didn't start that way. It took you a while. So, most children don't learn, a year. They're at a year, they're really good at listening. I mean, they know what you're saying, or your intent, or also your inflections, which is very hard to tell from text. So if you're a natural language processing person, it's really hard to tell what you meant. Like, for example, this meal is, this meal is, I'm trying to think, this meal is great. You say it that way. You say, this meal is great. You're really being sarcastic, that last one. It's like, it's not really great, but, this car is hot. Well, or you mean this car is hot? You mean temperature hot, or it's just an amazing car? That kind of thing. Hot is hot temperature, or is hot like a good, meaning it's good, it's great. So that's real tough to do. Not today. So what you want to do, so you cannot, it's going to be tough to get inflections here. Okay, but not today. We're just getting the data from the web page. The question is, you got to look at this a little bit and get some structure. Now, you saw the structure that it had like a date thing followed by the actual quote, followed by something else that almost looked like you can click on it, like the source, like where did this quote come from? Well, you know where it came from, but like, can you attribute it? Or, can someone document that this actually was said? That kind of stuff. So if you look at this, this is what we're going to go for. Okay. Now, this is just one of them. It's from March 22nd. So it's in the middle of, look, where is this at? What I got to ask? Wait. This is called parsed content. Oh, geez. I sometimes hate doing this infinitely long output cell thing. Oh, man. Goodness. Please tell me. I'm not going to remember this. I'm not going to forget. It's parsed.content. Okay. So, here, let me try this. March. Okay. Oh, by the way, this is cool. So, get used to Control F, which is fine almost everywhere. But I'm going to search for March 22nd. And here's March 3rd. Here's March 4th. Here's March 4th. Oh, we can't. Somebody said at least two things on March 4th. At least our data captured two things. And here's March 7th. Well, did he not say anything? The 5th, 6th? Probably not. He probably said something. It's just that it's not in this data set. It's not in this data. So be careful. So here's the March, and I forget what we're looking for. March 22nd. March HTML. Oh, there's a tag, I guess. Oh, wait. March 31. March 29. March 22nd. Here it is. So what is the thing we're going for? And this is where you have to be, you have to look at your text that came back from whatever tool you use to read the web page. Okay? That is the blue highlight. That is one, I don't want to say record. We'll just say record. A record is a day, okay? A date, a quote, and some attribution kind of thing. This is one of them. So it starts with strong meaning bold. There's many ways. There's a few ways to say strong or bold, I should say, in HTML. Strong is one of them. So there's a strong and a slash strong. Good. Don't ampersand. Oh, by the way, when you percent NBSP semicolon, that's a non-blocking space, only one. Spaces are meaningless in HTML. The raw file. But what you said here is, I want bold March 22 followed by a space, followed by some strange things here. Not right here, non-printables. You can't get them from a keyboard. These, okay. Hex E2. I have no idea what it is. A hex 9, a non-printable definitely. And C9C, I don't know what that one is. Well, and then it has some text. And then it follows, So this thing, I just said, I'm going to pick this one, March 22nd, so that we can look at it. Well, it's the same structure on March 29th. It's the same structure on February 3rd, whatever. So I just captured this and put this down here. So what you want to do is, I'm going to go for all these quotes. And we're going to write a file that has all these quotes captured, like 4 or 5 columns, day, quote, some form of attribution with a URL to also. Oh, if it has it, now remember, sometimes the data is not available. So here we go. So here it is. This is March 22nd. Oh, I'm going to get rid of this so that March ain't highlighted. So here it is. So it's in a span HTML tag. Now, span and div are roughly equivalent. That's all I'm going to say right now. Not an HTML class. So I'm going to look for span. Okay, I'm going to look for span. Oh, that's the HT. I'm going to do a hey, beautiful soup parser object dot find parenthesis quote span quote. Now, is there other spans? Yes. Well, what if there were many different kind of spans? Then there are. But you're saying no. I only want the one that the HTML attributes are class, and specifically the class that says short dash desk or short descriptor. I mean, so you can call this anything you want. Oh, the short descriptor. They call, in other words, you're a consumer, so you have to deal with their names. Okay, so you're going for find me the span with the attribute class equal to short dash desk. Okay, and what about the other spans? Nope, you didn't say that. You said only the spans with the attributes class and short descriptor. Okay, so here's one way to ask for help. Okay, there it is. Oh, you're going to be doing find and find all a lot in any parser. Okay, so there it is. A lot of these options, don't worry about these for now. But you have to supply it what you're looking for. Okay, and there's also this notion of if you're here, can I ask for my parent? Yes, you can. Oh, in HTML. So is it hierarchical? is HTML hierarchy? Very little. Like, where is this span tag? Well, we look inside HTML, there's two big tags. One is called head and one is called body. That's it. Of course, both of them are optional. So if somebody said, where would a span make sense? In the body. So if you're in a span, you say, tell me your, hey span, tell me your parent. And it could be nested, but it might come back saying, you're in the body. Lovely. That's important later. Advanced. Okay? So here we go. How do we use it? Well, import beautiful soup class from the BS4 package. Okay? So most people just say this whole thing, oh, just use beautiful soup. And here's the canonical form. Call it beautiful soup, please. Don't go crazy. Remember, BS4 is, you can't, that's a series, a bunch of .py files. It's a package. So you can't change this, okay? You can do an alias if you want. No one does it. Please just stick with what everyone else does so you can focus on the real problem. So here it is. Stamp me out a beautiful soup object. Okay, look at the response.text. This thing. Okay, look at this. Oh, no. Look at what came out of response. So it's the raw thing. You know, the one that tells you there's a status code of 200 and a few other things. Throw the HTML parser at it. And I'm going to start referring to what you see in a lot of documentation. So most people call it soup. Soup is the beautiful soup object that is the essence of, it's the parsed text of the web page. Now, folks, advanced folks, people out there, what is this thing really? This is what a beginning, okay, when you parse things, if you ever use compilers or even interpreters like we're using here, the first thing it does, it parses your text. It says, you gave me some text. Can I make sense out of it? Does it look like Python? Does it look like Java? That kind of stuff. So how does it do? It forms what's called an AST, abstract syntax tree. Tree is the important part. So if you ever hear of an AST, this is it. So what is soup really? What is this thing? It's a tree. And what you do, you and compilers work this way. There's a tree out there. It's the parsed version of the text of the web page. And then you query the tree. Okay? You query the tree and you say, do I see this? Find these. If I see that, do I have something under it that looks like this? Do I have something? So you query the tree by, in this case, find or find all. That's the ones I'm going to focus on today. Okay? So this is a tree. Okay? It's a tree. It's pretty elaborate down there. And then what you do, you say, hey, you know that tree, the beautiful soup tree? That's the version, the tree structure of the text that is the web page. Find me all these things. Now wait, you saw there was a bunch of quotes. So I expect a bunch of them out here. The question is, how many are there? Now, you may have seen 5 or 6 marches, but it doesn't matter. We're going to say, hey, by the way, how many did you find? He said, find all. Fine, tell me how many there are. So you do the length of it. Sounds great. Okay, so real quick, you said the first print statement is, it says it's a beautiful soup object. Yeah, you should not be surprised, okay? This one, tell me the length. Oh, there's 180 of them. There's 180 things that look like quotes, okay? Because we determined that span, in the HTML world, the span tag with the attributes class equals short desk is our definition of what we're looking for. It's a quote. Okay, sounds good. When I say quote, I mean, some humans saying it, in this case, Trump. Okay, and here it is. So there's 180 of them. What did it return to you? Oh, wait, this looks like a list. That looks like a list. So blah, 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 blah. That's the 0th one. That's the 0th quote. And it's from, if you look really close, January 21. We're going to break that apart. So we're going to write something to pull apart that one. Wait, is it the same one is it the same technique we're going to throw at this one? Yeah. You see the comma? This is results 1. And somewhere down there, there's a March 28th. But there's 180 of these things. And they all have the same structure. And notice they're all span class equals short desk. Now, of course, that's meaningless now. So we got what we want into this thing called results. Great. Now we got to drill down. Okay. So this whole this whole mentality of getting what we want and then refining it to get more detail. Okay. Or looking if it's the one we want. You know, in this case, you could span. I could write something really quick, not now, not today. Look at all the results. Look for anything that says Europe. You know, the continent Europe. I want to see what he said about Europe. Okay, sounds good. And you know, that kind of stuff. So I don't care about all the quotes. I only want the ones that Europe was mentioned. And then from there, you can do your natural language processing. How does he feel about Europe? I don't know. Let me get all Europe quotes. This is how you start. Okay. And by the way, this is not all the quotes. It's only like a few months. Okay. So this is the beginning. So results is a list of spans, which is basically our essence of what we want. And if you start looking, okay, enough of that. Results is that. So here it is. There's a lot there. Scroll through it. No, stop reading it. It's the same. There's 180 of them. You know, so we're going to pull apart one of them. Okay. Diagnose each result into a date, a lie, an explanation, and a URL. Oh, there's only 4 columns. Okay. So we're going to look at the 0th one. There it is. It's January 21. Right. And it says, I wasn't a fan of Iraq. I didn't want to go into Iraq. Okay, that seems to be a quote. Then there's another span within that. And it talks about, wait, there's a link. Okay, sounds good. Leave it alone. So results 0. This is it. You're saying, no. I only want to look at the contents. Oh, that's a lot better. Don't write. Okay, one of my mantras is if you start writing like a lot of loops or a lot of code, start thinking like, am I the first person to ever want this? Well, yeah, you're probably going to have to write that code, but you're probably not. So go looking for it. You know. So I'm going to say, how do I get the text out of this structure? Oh, remember, result 0. So we're going to do result 0 dot, result 0 dot. And we're going to try to encapsulate how we're pulling it apart. So we're going to say, look at the contents. Results 0 contents. So we're going to get rid of the span class equals short desk thing. And the trailing part that matched that one. Okay, so we're saying, look at the inside of that. And the length. Wait, it's a string. I'm sorry, it's a list. Oh, this is getting better all the time. Well, not necessarily better, but it's kind of helping us. So this is a neat one to start with because it's not brutal to parse it. Okay. I'll point you to the brutal ones. I mean, the ones that I looked at a few. So here we go. Lovely. And you say, well, a list is a collection of elements. Sure. That's the 0th element. Oh, that looks like the date. Cool. I can get that. Leave it alone. Okay, well, what comes next? Oh, look at this. It's a quote with a quote. And look at the quotes. The quotes are different. There's different single quotes and there's different double quotes, folks. Be very careful. So if you go looking for a quote and it doesn't find it, it's like, oh, it's that other quote. So be careful. So if you're scratching your head and trying to figure out why it can't find a quote, be very aware of it. So a lot of times you copy code that has quotes and it's like, I have an error in this line. You're looking at it for a while. Change the quote to what you expect. In Python, it's the quotes near the return key, the single quote and the double quote. There are reasons you use the other ones, not today. So there's the first piece of the contents, the blue part, and here's the third piece. So there's only 3 pieces. There's only 3 pieces in this length. I'm sorry, what am I saying? There's only 3 pieces in this, like the record or whatever you want to call it. Don't say record, but it's not. There's no structure yet. But it has structure because it's tagged. So, it's just not in a nice tabular form. Okay. So what you're saying is, well, if this is the date. So you say, hey, yeah, you know that thing above? I want the 0th one. You know the thing above, like right here? Get me the first one. So that'll be the lie, what we're calling lie. And this is the second one. Remember, 0, 1, 2. That's the attribution, I guess. It has 2 pieces. Yeah. So when you start pulling it apart, you don't know what you're looking at. So this is only hindsight. So, hey, show me the date, specifically only the date. Cool. Oh, wait. I don't care about the strong part. Yeah, stop writing code to parse this out and pull off the trailing and leading strongs. You have better things to do. That's what a parser does. Talk to the soup, in this case, results. Results is the soup of it. Talk to it and say, give me the contents of it. And so here it is. Good. We got the date, the lie, and the thing. But it's like, if you give this to the data science person, they're going to say, get out of here. What is this stuff? What is this quote? Is that the same quote? Like, stop this. You gotta fix it up. You gotta clean it up. Okay. So this is you using any trick you can to make it look clean. Okay. So we're gonna look at the date, then the lie, then the explanation. Okay. So here we go. Let's look at the date. So we're all about result 0. And there it is, just to remind you what it is. There it is. And what we're saying, result 0. You know what? We want to find the strong piece. Well, if you look here, where's strong? Right here. And you got to look at it really quick after a while and say, is there many strongs? No, there's only one strong, real quick. So this is so I'll just use find, and that will be the date. Okay, so you say, find me the strong. In that thing above, result 0, find me strong. And it says, there it is. It's like, okay, I'm not surprised. Wait. You could do things sometimes by indexing if it has something you could iterate over. Like, this was a list of 3 things. When you start using indexes, they're hard-coded numbers. And after a while, you don't know, what's a 1? What's a 0? If you look at this code, it's like, I'm looking for strongs. Oh, is it the same as index 0? Yeah. Please, write code that's easier to read. Try not to use hard-coded numbers if you don't have to. Okay? So find me the strong. There it is. Well, remember, and you say, well, this is a bunch of junk. I only care about that January 21 thing. Oh, wait, that's not quite what I want. What is this junk? Well, this is a string. So what you're going to do, same as above, and this is what we do in a Python course a lot. You start with something, then you iterate, make it better and better. And it's like, but if we just blindly just give you this, it's like, I don't know what's going on. So, you start with this, get me the strong. Yeah, lovely. That's get rid of those the HTML tags. Yeah, we say dot text. It was like, oh, this is not quite. It has a trailing Unicode. So Python does Unicode. It could be a smiley face. It could be weird diacritics on letters. Like German, almost every language has it. Like double dots above a vowel. German. Yeah. Well, where's that on a keyboard? It's not. It'll be one of these things. So this says, here's a hex character, X or 0X. It's a 0 character. Okay? So I don't care what it is. I don't want it. So what you're saying is, I want to get the text, and it's a string. So I want to say, start at the 0th one and go all the way from, except one back from the back. So if you're into, well, you better know this. It's a great feature. Other languages, to strip off the last character, I'd have to write some code. Python says, oh, you can do slicing. Start at the 0th character, go to everything, but not that last character. Not that 0x, I'm sorry, the /x, 0, A0, whatever it is. It's I don't care what that is. It's like, I'm getting rid of it. Bing. Oh, I ran it. There it is. I got it. Here's the code to pull out the date. I got it. Conceptually. We're going to pull it together. Okay, look at the lie. Here it is. This is weird. Oh, I don't like this. I'm going to not start at the 0th character. I'm going to start at the one. Okay, the first character. I'm going to lose that quote. That quote. Also back here, there's a quote I want to lose, and also that wacky character. Whatever it is, I don't care. So you're saying, don't go 2 back from the end. Okay. So yeah. So this is slicing. Normal boring Python. Hey, that's good. I got the lie. Well, the question is, do you like the quotes or not? I don't know. Yeah. So we got rid of the crazy stuff at the beginning and the end. Okay. Lovely. Now here's the explanation. That's the second one. So just a reminder. Here's result 0. Here is that's the third one. It's a if you look really, really close, I could search for span with the attributes class short dash truth. Yeah. So there's not always just one way to do things. So you say, look, I want I want the URL. Okay. And the part that says he was for an invasion before he was, that thing in parentheses, but it's not always in parentheses. So don't always count on that. So I'm looking for an A. Oh, an HTML tag A. And by the way, there's only one of them. So I don't have to look for all of them. Okay. And we're only looking at one. So here's an A. Oh, here's an A. Hey, I got the A to the /A. Okay, remember we're parsing HTML. Okay, well, I don't want the A blah blah and the /A. Well, give me the text. Yes. Now the question is, do you want the parentheses or not? Or do you want the quote? Remember, it's a string. So you're saying same as above, but lose the opening character, which is an opening parenthesis, and lose the trailing character, which is the closing right-hand parenthesis. Good. I'm done. Oh, no, I got the English explanation, but can I get to that URL? That thing. That. Okay, so that's the href piece. So here's again. Let's look at the whole thing again. There it is. Find me the A. Oh, wait, that's the same as the above. Sure. So far, so good. Not surprised. But you're saying from there, get me that tag. So this is indexing with a string. Interesting. Now, you say, I've never seen that before. Oh, yeah. Dictionaries do it all the time. Oh, Python do it all the time. That's the key. That's actually not figuratively. It's actually called the key. So there's a bunch of A tags, and href is a link, a hypertext reference. Okay, so you're going to get the URL. Bingo! I'm done. I got it all. I got the 4 pieces I want. I pull it together. So here we go. Start with a blank list. And call them records. Okay, remember, how many should we get? You should get 180 of them. 180 quotes. Great. So here we go. Date equals. Now, if you saw this code, if I just gave it to you, it's like, I'm out of here. But you know a little bit. So here's how you get the date. You say, this is what we saw up above. Result find strong text 0:(-1). Okay, yeah, but I decided, what if I start concatenating this stuff with a bunch of quotes that I gathered from multiple sites? I might. Oh, this happens. You don't get data from one source, one website. You'll get it from multiple websites, multiple days, all over the place. Okay, and I might add another column saying this is the URL I got this record from. If I'm going to concatenate a bunch of these, tables, rows and columns, I will want to know where did I scrape that record from. I might want to do that. But here I just said, you know what? I'm going to put a year on it because I'll be scraping a bunch of years, and it's like after a while, it's like, what year did he say that? Well, I know he said it on March 22nd. I said, yeah, but what year? So this is in 2017. So I'm going to take whatever I did above and I'm going to put on a comma space 2017. Sounds good. Here's a lie. And if you look up above, that's exactly how he did it. Nothing fancy. I'm not changing that. Well, the explanation, yeah, that's the stuff that looked like it was in parentheses. The English, that's like an English explanation. And the URL, wait, that's the same as above. Just tell me where you got that stuff from. Now, you got 4 things: date, lie, explanation, URL. Call it anything you like. They're nice variable names. Okay. This is a list. How do you add stuff to a list? There's many ways. The one you want to learn about is a classic. Start with an empty list. Get your new record or row. Get it somehow, wherever. And then what you'll say is, you know what? You know that list that I'm currently building up? Append to it whatever you want. I'm appending those 4 things to it. And it puts it on the bottom by default. I don't care about inserting it. I'm putting it at the top, putting it in the middle. You can read about those. Most people just append at the bottom. So append is at the bottom. So there it is, and it's going to go through the next result, the next result. So this loop is going to go 180 times, 0 to 179. Okay, and print the length of the records. Yeah, well, depends how you feel about this. This is kind of a personal thing about Jupyter Notebook. You put all of these in one cell, or you put them in 2 cells. It's very much up to you. So I'm going to run this thing, and it formed records. So records, tell me how big you are and show it to me. Okay, I'm going to even do it more. So the length of the records, you expect it to be 180. Oh, I ran the wrong one. The length of, you expect it to be 180, that's true. So say, okay, that's a good thing. If you didn't get 180, start thinking. Remember, because we know there's 180 of those span, I already forgot, with some attributes, class equals something. Short dash desk, I think. There's 180 of them. And look, if you read this, oh, this is a list. And by the way, what is this? That is a tuple. I said I want it to look like a tuple. Now, a tuple is just unmutable, meaning you can't change this data. So there's going to be 4 things in this tuple. Write it out as one record. So here it is. I better not say right. Append it to the list. So here's a list. Here's a tuple, the 0th tuple. Look, that's what I mean. That's what you see, the opening parenthesis and the trailing parenthesis. Then here comes the next one. So it's a list of tuples. Now, be a list of lists, sure. Can it be a list of I wouldn't want to make it a set. Can it be other structures? Yeah. A list or a tuple makes sense. Okay. So that's kind of good. You say, wait, this is almost good. You give it to a data science person and say, look, dude, can you just give me a file with this? Yes. We want to write these things out. So there's many ways to write things out. Meaning persistent. You can write it out as a pickle file format, PKL. Don't worry about it. It looks like a list. That's one data structure. Pickle will do it. But your data is writing in whatever language. It's like, what's that? What is that? What's a PKL? It's like, give it to them and give it to them, whoever, in things that they can understand. A CSV is universal. Okay, and this is not infinitely big. So CSVs are brutal if they're infinitely big data. It's definitely not the structure to go to for large data or big data. Okay, so here we are. We're going to write it out. Say, hey, we're going to use Pandas to do it. Okay, so let's create a Pandas data frame. Now you can create a Pandas data frame for anything, almost anything. It has to look like an array-like. A list looks like an array. Oh, it's array-like. Okay, so I can iterate over these records, and somebody can. Pandas can do it. So Pandas, create me a data frame. with that data from above and give it to the column name. It's really a nice person. There's CSV files that have column name and ones that don't. So the ones that don't have a column name, you have to start thinking. It's like, oh, what are these columns? Well, I'd like to put the column name in there. It's date, lie, explanation, URL. Sounds good. And show me the first 5. Yeah, 5. There it is. Wow, this is nice. It's very nice. Okay. And, and by the way, it's in this thing called DF. So that's a default variable that a lot of people use if you're only doing one data frame. If there's multiple data frames, you'll give them different names, not DF, DF1, DF2. That's bad. But data frame, most people just say DF. Don't go fancy with it. Call it something else, or even your variable name. You can call it quotes underscore DF. That way, it's like what's it? Look, it's a data frame by the way you named it. So I'm just preaching, I guess. Here we go. So this date column, not cool. This is not the default file format. I'm sorry, it's not the default date format of like Pandas. It's just a text string. It says J followed by an A followed by an N dot space 21. I guess this is a space comma space 2017. Yeah, that's a string. You can't do any date manipulations on it. So the date string manipulate date time. There's a module that deals date time. You can say, give me hours, give me minutes, give me the second, give me the day, give me the hours, give me whatever I missed. So date time structure is really cool. Well, Pandas supports it. And when you create things, it's usually called TO underscore. Okay. So you're looking at the date column of the data frame. That's this column. That one. You're saying create it to a date. Take it, convert it to a date time. Okay, I got it. What do you want me to do with it? I want you to put it back into the same exact column. So pay attention. Oh no, you'll see it. It's not like I'm going to. Wait, this is a default representation. This is a date time object. So df.info. Right, you see it? Date time there. If I ran it up here, it would say the date is an object. Everything is an object. Now remember, that's because it's not an int, it's not a float. It usually defaults to object. But there's also categorical data type. None of these are categorical, so I'm not going to convert any of these to categorical. But please convert your data types before you write them out to what they really are. This is date time. Stop giving me a string. Give me a time thing. Okay. So here it is. All we got is that, and there's 180 of them. So if you wanted to look at the shape, okay. So this is a review. Data frame.shape. Pandas is only one dimensional or two. This should be 180 by 4. 4. Yeah, 4. And so remember, this is the index. That doesn't count in the. It's not a column per se. It's record keeping. Same thing with the column name. Is there 181 records? No, that top one is not. That's like helps you to talk to the data with a column name and a numerical index for the record. Okay, got 180 by 4. Lovely, great. Question is this. So pay attention now. I want you to look at this. No Trump. I resized. Oh, come on. Okay, so we're going to write it out now. We got the Pandas data frame. Pandas, you got a Pandas data frame. You can easily write it out. You feel like writing it out as a PDF file? Go for it. You can write it out as anything. We're writing now, so we're not using Pandas to read today. So here we go. So what this says is, hey, you look at your structure right here. If Trump lies exists, delete it, pre-delete it. So if I said operating system remove and it's not there, it'll yell. So he's like, hey, does it exist? If it exists, then delete it. That kind of stuff. So sometimes when things yell, they're annoying to look at. So just say, how do I check, pre-check? So if it exists, then delete it. So and here we go. This is percent is a line magic in Jupyter Notebook. A lot of them look like Unix commands. So this is a listing. In this case, in this way, it's a directory. So it's like a dir. So start learning these things, if you're going to get heavy into Python, not Python, but data science, you'll want to know a few Unix commands. Okay. So, it says, show me anything that looks like Trump, anything. Oh, there's nothing here. So down here, I'm going to write it out. So Pandas has a bunch of files, a bunch of methods. Read is for read. So read underscore CSV, read underscore PDF, read underscore this, read underscore HDFS, that kind of stuff. The equivalent is not write underscore, it's TO underscore. So TO underscore is writing that kind of file. So it's going to write a CSV, and I'm going to call it Trump underscore lies, and the index. I don't care about the index. I don't want to write a 0, 1, 2, 3. I don't care about that index. I don't care. So it says index is false. By default, you get it. And when you read it, then it puts on indexes on top of the indexes. So if you ever say, wait, it's getting me duplicate no, it's because you don't write indexes out, usually. There's reasons you want to. Not a topic for today. And encoding, this is a UTF-8. That's 8-bit code. So it's ASCII. So there's no weird characters, no smiley faces, no heart shapes or anything. Okay? So I'm going to write this one out. Didn't run. Pay attention up here as I run this cell. Oh, there it is. It just got created. It's 52K. Sounds good. I'm gonna look at this. By the way, I double clicked. I think I did. Oh, the thing's shaking. Sorry. And there. Oh, opening. It is opening. So it's going to be like 2 or 3. There it is. Good. And there it is. And this is this is the like the Excel equivalent on a Mac. So there it is, and it's really cool. It's really nice. Okay, great. So it looks like a CSV because and it is a CSV. And if you look at the data, open with some text editor, text edit. Okay, you'll see it there. So it's the 0th line or record, or whatever you want to call it, is the column names, and then we start dealing with each of the data, 1 line per record, and it's separated by a comma. Okay, and yeah, that's kind of cool. Yeah, we produced that, minutes ago. Oh well, gradually, but we finally wrote the file a few minutes ago. So let's look at the structure. I'm sorry, let's look at the directory. Yeah, there it is. Don't worry about all this stuff, but yeah, it's 52K. 24-hour clock, so 240. Yeah, there it is. And you can look at it this way. This says go out to the operating system and do it. You could do it. So here's a better way. Use Jupyter Notebook. So it's operating system independent. Cat. And cat is a concatenate, and if you do it this way, it's kind of a list. There it is. Oh no, it's infinitely big too. Sorry about that. So %cat will work on it's a Jupyter Notebook line magic, so it will list, in this case, a file. It does concatenate, but the way we're using it. And if you put it all together, here it is. Here it is, and I'm going to just change this to 2, just to tell you it will produce another one. So here it is. It's all put together in one cell. Now, if someone gives you this cell, yeah, they're going to take some thinking, but we did the thinking up above. So this is like, yeah, we know what this is, but I pulled it all together in one cell, in one .py file. So this is one .py file. If you were to give it to somebody who is not like a Jupyter Notebook person, just give him or her that thing, and you'll be good. Okay. Now, if you say, can I throw this at another URL? No. Oh, well, most likely, yeah, you can. But it won't work because this is looking for certain things and then trashing the last character and then adding, this is very specific to that URL, meaning that web page. So, transferring this to a new web page is probably fruitless. It just start with, get me the text, get me a browser that matches that parser. If it's JSON, do a JSON parser. If it's XML, use an XML parser. Great, sounds great. And start finding stuff that you look for. So this is very specific to that web page. So if it breaks, yeah, it's because they changed something, not your code changed. Okay, so if you run it, there will be a Trump Lies 2 coming up, and hopefully it's the same size. I assume they're the same. I'm not going to look. I'm not going to do a diff. Now, real quick, Baby Yoda images. I'm almost sure this is not going to work. So here we go. It worked once upon a time. So you say, well, go. Okay, first of all, go to the place you're going for stuff, and if it's dramatically changed or moved or things, you're not going to find anything. So Reddit, come on. Oh, it's so alive. Don't know what they call that. Maybe that's some kind of Yoda picture. There's a Yoda picture. Oh, there's a bunch of Yoda. Oh, baby Yoda pictures even. Not even the big Yoda. I don't even know what that has to do with Yoda. But that's the Yoda finger. It's a ring holder. Anyway, so there's all these baby Yoda pictures. Lovely. Can we get them all? Oh, I just want the images. Can you somehow get them? And here's where I was ultimately going. And it was like, let's see if it works. I don't know. It did work. I'm just going to run it. And what is it producing? Oh, just a bunch of images. Okay. So here we go. It's still thinking. 52. It created something. I don't know if you saw this move. Oh, look at all these baby Yoda pictures. Did you see that this just got harvested? So some people call it harvesting, but most people don't say it. They say scraping. But did you scrape a website? Yeah, for images. I only cared about images. So how do you care? How do you search for images? You search for the HTML tag IMG. Okay, specifically. I think I don't know. Wait. Oh, come on. There it is, right? No, that's it. No, sorry. Yoda. Oh, it actually worked. Well, I don't know. It got some pictures. Oh, come on. There it is. So I'm looking for image. Only things that look like, image attributes alt equal post image and widget image and this thing. Now, if this thing's changed, I know these people changed a lot. You can't, okay, it has to be IMG. They can't change that part. But the question is, are there a lot of images on there? Yeah. I only want the ones that have something to do with Yoda. I don't care about the image that is the image of the banner of your web page. That's not necessarily Yoda. It could be just a big letter, hello. It's nothing to do with Yoda. So here we go. So there it is. There's apparently 8 images, and cool. I'm impressed that it still works. Oh, now is that really a Yoda image? So I don't feel like doing image processing. I mean here, but how good do you want to be? So if I'm writing for example, why do I even care about this? Well, just say I want to write I want to create a neural network that is able to classify Yodas. I give it a picture, it says it's Yoda or not. It's Yoda 90%. It's Yoda 95%. It's Yoda 10%. Yoda 10%, it ain't Yoda, okay? It could be a bicycle or something. So you train it. In this case, it's only one thing. It's Yoda or not. That's the binary classification. Well, I need a bunch of Yoda pictures. I need a bunch of Yoda pictures. No, 8 is not enough. I want to throw things everywhere. Get me some Yoda pictures. So I'm going to, and don't do it by hand. Because I'm not talking about 8. I'm not talking about 100. I'm talking about a lot. So it's convolution, neural network, it's image. So you say, here's Yodas, here's not Yodas. Or, you don't say, trained in well, I need a bunch of Yoda pictures, and there they are. Now, is that a Yoda picture? I don't know. But it had one of those tags I was going at. That, no, there it is. It's just pure text. Yeah. And no, that's absolutely nothing to do with Yoda other than who owns them. That's a baby Yoda. So this is kind of cool. And this structure is a little bit more involved. And you can see I put out some details as to how I was processing it. And so there's some print statements in there. Scraping, yeah, I gotta do some more there. But web browser, it creates a web browser. So it creates a web. Oh, it looks at the URL, tries to open up the URL. If it's successful, then what do you do with it? And the classic is you open up just a browser tab. Wait, programmatically did this. Oh, there's 3 of them, so I have to look at that code. But they're all the same, so I'm just going to show you one of them. Music of some kind. Oh, man. Yeah, music. Okay, great. Sounds good. It's an hour long now. I feel like looking at it. But what do you want to do to programmatically open up a browser tab? Yeah. And, use web browser. Okay. Now, real quick. I'm going to look at regular. Oh, see all these baby Yoda things. Hopefully you got, if you ran it, you'd get 8 of them too. You run it like 3 days from now, you'll get more or less, depending how they change their website. Okay. So baby Yoda's, it's kind of neat that you can process things. Are images data? Yeah, if that's what you were going after. So here we go. I'm going to look at RE really quick. Now, this is regular expressions. You'll want to get a cheat sheet, a paper and pencil next to you to jot down like 2 or 3 things. Okay, maybe 4 things about how you do pattern matching. So this is all about pattern matching, and it's this part. You want to write these down, okay? Because I always forget them, okay? The reason is, okay, by the way, regular expressions is not a Python thing. So if you learn regular expressions in a generic way, very important. So it's an advanced search. For example, I want to find like wildcard. Star is the most generic wildcard. Not this star. Well, star meaning asterisk. So you say, I want to search all the files. I want to find files that begin with dog. You'll say directory or ls dog star. Well, we'll find a file called dogma.txt. Yeah. Well, it has nothing to do with dogs. Yeah, but it started with dog. So that's the most simplest wildcard that says, show me any amount of characters. So write these things down. Write down question mark is 0 or 1. That's important. Okay. So if you do HTTP question mark S, what it says is, oh, by the way, this is so it finds, you're saying HTTP. I want to find HTTP. And that S character, I'm willing to accept 0 or 1 of them. So that question mark modifies the last thing. Usually it's a character, unless you do something special, and we'll get into that in a brief time. Here we go. So you're saying I'm willing. So if you say HTTPS, what is it going to find? It's going to find HTTP or HTTPS, because you said 0 or 1 S's. 0 or 1 happen. You need that a lot. Plus says 1 or more. So that means and HTTPS plus is kind of silly. That'd be HTTPS, HTTPSS, HTTPSS. I mean, S, that makes no sense. So if you just do A plus, so it'll return A. Oh, it'll find A. So what's more mean? It could be infinity. Okay. So circumflex or caret, that says I have to find whatever it's modifying at the beginning of the line. That's important. Sometimes you care about the beginning of the line. Sometimes you care about the end of the line. So that's the dollar symbol, end of the line. End of the record, end of the string. So you're pattern matching in a string, okay? Enough of that. Let's go here. I'm just going to run this thing, run these 2 real quick. I guess I didn't run this one. Okay, here we go. import regular expressions. Yeah, you can ask for help many ways. I'm not going to go there. What are the attributes of RE module? So it's one file, believe it or not. And so here are the attributes. Some of them were pretty good. So leave us alone. What's a thing you want to know about? Well, special characters map. I don't talk about all of them, but here's special characters map. Yeah, these are weird characters. These are not alphas, and they're not numerics. So so this is the character of, is that a brace? Left-hand curly brace is a character 40. Anyway, it's like, well, okay, so there's all these maps. So get into that idea of a map. It associates one thing with another. What's its data type? Well, it's a dictionary. Can you look at the values? Yeah, the only reason I want to look at the values. Real quick, you can click on this, make trans. Okay, I'm clicking on this, and I'm clicking on replace. A lot of times when you want to change things, you want to map this character to that. So the simplest one is one-for-one character replacement. I want to squash all the digits. If I see a 0, make it a nothing. If I see a 1, make it a nothing. So because whatever you're looking for, numbers, digits mean nothing. First you want to do, get the text. Things you want to do, but force it all lowercase. Well, that doesn't do anything with the numbers, the digits. Okay, digits. The digits. I don't care about digits. Kill all digits. How do we kill all digits? Stop writing that code. Okay. So, okay, I invite you to look at these things. Okay, and make trans makes a trans. So you're saying, make a 0 a none, make a 1 a none, make a 2 a none. NONE, meaning nothing. Don't make it a space. Make it an absolutely nothing, meaning you're killing digits. Well, I want to kill all lowercase. Can I kill all lowercase letters? Sure. Can I kill uppercase letters? Can I kill all letters? Yeah. For some reason, get rid of everything. It's like, yeah, but you'll end up with these weird things. These are not letters. These things here. So most people real quick get rid of punctuation. The question is, how do you get rid of punctuation? So one is this way. There's a string thing, and you got it. It's just that these are not coming up quick. Here it is. So here's a real quick one. A one-for-one substitution. I can text A, X, B, Y, C, Z. Okay, there's the text. I want to replace an A with a 1, a B with a 7. It's an example, okay? And a C with a, Unicode. So I looked up, I wanted to not offensive, so I said, what's the Unicode for hearts? Apparently there's 2 hearts. There's that heart and there's that heart. So this is one character. This is a one character substitution. So it's called a table or a map or mapping table. So here we go. I'm just going to run this. So it did A, X, B, Y, C, whatever. And it says, when I see 97, that's in a lowercase a specifically, I'm going to make it a 9, meaning the ASCII, which is a 98, right? See, A is 97, lower, a B is a 98, and a C is a 99. I'm going to map them. So when you see lowercase a, no, I don't want lowercase a. I want you to make it a 1, a B, and the 99, I want you to make a smiley face. No, a heart. And I specifically had to look it up. No one knows Unicode. Memorized it, okay? So what you do is you make a translator, and you apply it.
Ed, sorry for interrupting you. We have 2 more minutes to go, so you might need to.
2 minutes, not follow up.
Yeah, just 2 minutes.
Oh yeah. Okay, so I'll summarize. So one-for-one character substitution. Look at make translator and translate. Really kind of cool. So if you see it here, that was an A, that was a B, and this was a C. Okay. What if you don't replace is one that a lot of people you see. Now's the time for all good mice. No, that's not how it goes. To come to the aid of their country mice. No, not cool. It's not mice. You're saying replace mice with men. Wait, that's 4 letters. This is 3 letters. So it worked. Okay? I want to replace all mice with nothing. When you start pulling out stuff, parsing. And I invite you to look at these punctuation things. So do I want to pull out punctuation? Be careful. Some punctuations are important. So what do you pull out? You don't pull out things wildly. So here it is. Look, find all. So I'm going to just go right to the punchline. So remember, the question mark and a plus, you'll see that a lot. So I'm going to go right to the end, okay? Because this is the summary. Look at these useful patterns. Oh, by the way, so here's a number. This says go to the beginning of the line. No. If at the beginning of the line I see 0-9, that's 0 or 1 or 2 or 3, 4, 5, 7, 8, 9, star. What does star mean? Star means the classic wildcard, 0 or many. So if I see, this is the definition of a number at the beginning of the line.
Sorry for interrupting you. It's 3 o'clock. We got to stop here.
Okay, we're stopping. So look at the useful patterns, folks. Okay.
And thank you so much for the great presentation.
Go through this if you have any questions.
Yeah, thank you. If you guys have a question, you know where to post your question, and we will be more than happy to address them accordingly. So we'll see you guys next week. Next week we are gonna have another topic, and it is gonna be an advanced topic using machine learning, and it's topic modeling. We are gonna use a library called Json to learn how to model, some text data. So until then, you guys have a great evening and great weekend, and bye everybody. Hope to see you next